This is lesson 7.4, solving equations with exponentials and logarithms. In the future, we're going to have to be deriving these kinds of functions, and we're going to be trying to find the minimums and maximums, which of course mean we're trying to find when those derivatives of these functions are equal to 0. So we're going to have to work on solving these equations. So in this lesson, our objectives below are to make sure that we can use proper order of operations and solving techniques to solve these logarithms and exponentials. We will also just very briefly review properties because sometimes we do need to use properties to help us solve and condense these problems. So the order of operations, of course, I've included the L with the E. Note how multiplication and division, those inverses belong together, subtraction and addition, so do exponentials and logarithms. So here is the order. So moving forward to find the end result, that's when you use the PLEMDAS. So it's kind of a big deal when I forget things at school, and I totally forgot my pen that allows me to write on my PowerPoints. So this is going to be kind of weird. I had to write all the steps out, so that's why this video is the way it is. So just be aware of that, but use PLEMDAS moving forward to find the end result. If you are given this function, don't forget that, hey, alright, I need to find some sort of end. What I do want you to make note of is if you were to type this into your calculator and you did not put parentheses around what was in this exponent place for this exponential, you would get the wrong answer because your calculator would do 4 to the third first, and then it would do the rest of the operations. What you wanted was 4 to the and all of this done, so you would have to put that in a grouping. So just be aware that whatever is in the exponent spot of an exponential, you would have to put in parentheses if it's more than one operation. So by order of operations, we would do what was in parentheses first, right? And multiplication, of course, would come before that, subtraction, so we'll do that. And then again, we still have these parentheses up here that we would have to address. Oops. Oh. Okay, and so here we would do that subtraction now. You would get this. And then of course we're going to do the exponent. So here we're moving right along our PLEMDAS. And here we would do multiplication times that by that 3. So going down. And then addition, of course. So we would get y is equal to 13. But now if you wanted to go with an expression like this, note how you know the end this time, and of course you don't know something at the beginning. So it's like the movie, I ruined the end, but now we have to get back to the beginning, so we rewind. And of course we would have to go in the exact opposite order of what we just did here. So addition, we added 1, so of course in this case, what we're going to do is get rid of that addition. We're going to subtract that 1. So note how we're going to be, there was my addition for that last step. Now we're going to be going backwards with the inverse operations. So this is what I would get when I subtracted that 1 to both sides. And then we're going to undo the division this time, just in the proper order again. And then here's where you would have to do a log. Oh, sorry. Log base 4. Oops, sorry. Again, my pen. And then whatever you do to one side, of course you have to do the other. And the only reason I'm doing this for this step is because this is kind of our new step on doing with logarithms and exponentials. So here we would log it, and then of course this right here, log of 4, log base 4 of 4, we're asking ourselves 4 to the what equals 4? Well, that's just going to be equal to 1. And then, of course, those canceled each other out, so it brought down our exponent and brought it down to a base. And then we're going to undo addition, just like we were doing subtraction. We had to do addition, and then division, and then we got our answer. So, of course, we wound up right back where we began. Alright, so you need to reverse if the end is given, and you need to rewind to find the beginning components. Don't forget these. You already have these written down from the last section, 7.3. I just want you to keep them back in your mind to make sure that you're remembering these properties, because sometimes they can help us condense a problem and solve it a little bit more efficiently. All right, so here's your homework. Don't worry, I am going to be working through one from each section here. Here is our first example. It's our example 1, problem number 1 from the homework set. So they are giving us a situation where, again, we know the end this time and we're trying to get back to the beginning. So we are going to be using our reverse order of operations. They do give us values for x, and then in the directions they're asking us which values of x that are given are actually solutions. So what we want to do is determine yes or no for these particular solutions. Sometimes there's all of them ending up to be true, sometimes none of them ending up to be true. And again, solutions are just the values that make a statement true. So one way to do this is to plug them in and to see if they do make true statements, and then write if there are solutions accordingly. But instead, what I would like us to do is work on these inverse operations. So keep in mind, this exponent is in a grouping, so this is a grouping. So all the subtraction, addition, division, and multiplication that are all in this grouping can't be done, so we're going to go right to the exponential, or exponents and logarithms, to undo. So I am going to undo the fact that this is an exponential by logging both sides, log base 4 to get rid of an exponential base 4. Those cancel each other out. Now this expression has a couple of different ways we could go about evaluating it. I am going to go over both. Now, you're more prone to probably just use the change of base formula, because that way we could just type it into our calculator, and you could do that. But I do want just to refresh that we could also do this by hand, by asking ourselves, a logarithm is really asking 4 to the what equals the 64. So I've set that up now as an exponential. And then we would try to rewrite 64 and 4 to have a common base, and 2 would be it. So we could rewrite 4 as 2 to the second, we could rewrite the 64 as 2 to the 6, and then in this case, now we would have 2 to the 2, x, right? And then equals 2 to the 6. Sorry, this is kind of painful. But here, we had a power to a power, and don't forget your exponential properties, that you would just multiply those exponents, so that's how I got this. Now if you log base 2'd both of these exponentials, it would bring down that 2x and that 6, and then we could just solve. So whether or not you do this on your calculator, we have to evaluate this expression, so we would get this. So now these are your basic algebraic arguments, and then you would get that, hey, in this case x would have to equal 5, so you could go up here, this is a yes, this is not, because this was the only option that we got. Example number 19. This is what they gave us, and they are asking us to evaluate. So here is our expression, and it is set equal to 0. Again, we are trying to solve back at what is the x value that will make this true. So a lot of you might already kind of suspect that, hey, this is just going to be 2. But let's go ahead. Don't forget that we could use some properties here. We could actually condense this into one logarithm, and that way we could just condense this whole problem to make it more efficient to solve for our x. So I am going to use our quotient property. So I took this, condensed it, and then now we have a natural log of x divided by 2. So again, using our order of operations, this is in a grouping, so normally you would think, oh, let's undo division, but no, this is parentheses, so we have to undo our exponential, or our logarithm. So we are going to base e both sides, and that creates exponentials on both sides of this equation. These are going to, of course, cancel each other out, because these are our inverses. This is kind of our whole point. And then we're going to just get x over 2 equals 1, which we could easily solve for, and could see, like I said, our solution x equals 2. Alright, in your set from 35 to whatever, you were asked to simplify. So again, what they're just asking you to do is really recognize, hey, gotta undo these inverse operations, and x to the second is what we would have left. That's all we can do at that point. It's as far as we can go. I meant to save this for the end, but this is our major kind of goal here, is to find zeros of our functions. And again, that's going to come from when we get into our next chapter, we're going to be asked to find minimums and maximums of some logarithmic and exponential functions. So in order to find minimums and maximums, if you can recall, we derive and find when are our rates of changes equal to 0. So what we're kind of doing is we're trying to find those x-intercepts of our derivative graphs. So here, this is our function, and we are going to just set it equal to 0, and we're going to solve. So over here, this red line is our graph. And technically, you guys could do these without your calculators. You could notice that this is a multiplier. We would have some sort of multiplier on our x, which would be a horizontal stretch and shrink. This was a vertical stretch, and then this was a shift down. So you can kind of imagine how this is happening. We also had this negation. So normally exponentials go up, right? But because this was a horizontal translation or a horizontal flip, this exponential that would have normally gone like this is going to be taken and flipped over our y-axis to create this downward scoop, I guess, or our downward exponential decay. So there's that. But anyhow, so you can just go ahead and graph these on an online calculator or your graphing calculators, and at this point what we just need to do is solve. So I am going to undo. This is again in groupings, and I will undo any subtraction or addition first. So I would add this 11 to both sides, and then at this point I am going to undo what's not in my parentheses, this multiplication. So I'm going to divide both sides by 8, now getting it to this point. And then I am going to just leave these. Most cases you're going to get decimals that are non-terminating, so they go on forever. So we want to try to clean up as much rounding error as possible, so you can just leave these as a fraction. Even though this one's it's a terminating decimal, we're just going to leave it as a fraction. So now we are going to do our natural log of both sides. If you natural log this side, then of course you would have to natural log the other side, but the whole point is to undo that exponential base e with a logarithm base e. Oops, sorry, disregard that. And then this is what we get. And then now we can start undoing what's in here. So, oopsies, sorry. Move on to this step. So we would want to undo the division of 3. So we would multiply both sides by 3, thus getting rid of this. And then now it's showing up over here. And then finally we're going to divide all of that by -2. If you were to type this into your calculator, please just make sure that you put these in parentheses, and you would technically have to put these in parentheses as well. So double parentheses around the top. When you type that all, sorry. When you type that all in, sorry, you're gonna get this. So just be very careful about how you type that into your calculator, and you can see from the graph that that's where you would expect it to be. That's it.